This is Duke University.
I spoke at this event last year, and it was fun. At that time, I actually presented the initial results from the stated preference experiments that we played with people to try to understand preferences for improved cook stove technologies. And so now this year is the follow-up where we actually have field data from India about what people told us in the first round of baseline surveys, if they actually did adopt stoves as we thought they might, according to those preferences. So I'll present that results. Okay, so the motivation for this talk is kind of this general problem of biomass burning stove technologies, which generate a lot of air pollution worldwide, and it's been implicated in global climate change as a producer of black carbon, which is a short-term climate forcer. Also, some negative impacts on household well-being in terms of health, because smoke emitted in these confined spaces within the household lead to lots of respiratory disease and other negative health impacts. There's also a lot of time associated with collection of fuels in many lower-income countries because people may not have ready access to forested lands and may have to travel long distances to collect firewood. And then finally, there are some kind of local environmental problems that result from this kind of deforestation that happens, including impacts on watersheds and impacts on biodiversity and ecosystem services. So the motivation for improved stoves is that by addressing this problem, by creating more efficient fuel burning technologies, you could avoid many or reduce many of these negative impacts, which would deliver benefits to households, but also to the wider global community. Unfortunately, there's not a lot of evidence from the field on interventions that really do work and deliver a lot of benefits for people. So the motivation behind the study that I'm going to describe was to try to see if we could find ways to stimulate adoption of these technologies. One of the big problems has been that people don't seem to adopt a lot of the improved technologies because they may be hard to use, they may not fit their needs, et cetera. But also to try to explore some of the factors that might be associated with successful interventions. So we wanted to experimentally vary some elements of our intervention strategy to see what actually works to stimulate adoption. And this is kind of answering to a growing body of evidence that suggests that people don't use these technologies for long periods of time, that they maybe have low demand for them initially, and sort of speaking to this demand side barrier. Okay, the paper that I'm going to present today is specific to some results that we collected on preference in a baseline survey for different aspects of an improved cook stove technology, and then seeing how and whether that predicts behavior during this actual experiment. And so what I'll do is describe initially how we did these preference experiments. Some of you may have seen that last year, but I don't assume that. And then I'll tell you about the intervention and how we designed it to test whether these preferences actually do explain anything. So our field site is in rural India. It's in a mountainous zone in Uttarakhand. These are the foothills of the Himalayas. So foothills is 8,000 feet above sea level. It's pretty high. And you can see from this picture that there is, some woodland area, but it's pretty heavily deforested. There's a lot of population pressure even in this zone, which is actually lower density than some parts of India. And these are traditional cooking technologies. So people will have, this is I think it's a 3-stone fire just with an alcove within the household. And people will put fuel underneath the pot and cook that way. And so you can imagine that this generates a lot of smoke in the household. Very few of these kitchens are ventilated. Some of them are. And there's a lot of inefficient burning that happens in this type of stove. One important aspect of our design that I just want to highlight as we move forward here is that we worked with a small NGO that was based in these zones that we were working in. And we deliberately designed our sample such that we would ask them to promote stoves both in villages where they had a prior history of working and promoting a variety of livelihoods improving technologies and education programs, and also communities where they had no prior experience working. And we tried to ensure that those two sets of communities were as similar as possible based on observable census characteristics such that we could test whether the history of this institution also made a difference in terms of adoption behaviors. And so I'll show you a little bit of the results that pertain to that as well. Okay, so 3 essential components to the study. The first was we did these detailed baseline surveys collecting information about stove use behaviors, fuel, how people cooked, and did these choice experiments with households where we asked them to select their preferred option from among a set of different options. And I'll show you what those choice experiments looked like in a second. Then we have the stove intervention activities where we promoted these technologies, tried to induce adoption. And then finally, we followed up with a set of surveys where we measured a lot of the same things we measured at baseline, but also tried to observe if people had changed their behavior after this intervention. So the discrete choice experiment looked a little bit like this. Each household would get a series of cards like this where they had 2 different improved cook stove options and a traditional stove option. And these were differentiated by things like price, smoke, fuel, and the number of pots, so the convenience of that technology. And these pictorial representations would show how much of the fuel they needed, how much smoke would be produced, what the price would be. And each respondent household got 4 of these cards with different combinations of these different changes. And they were told each time, select your preferred option, and then confirm that you would actually purchase it at that price if they chose one of these improved stove options. So we observe a repeated set of choices for each of the households this way. And when we analyze data and what people seem to respond to, they respond in the way we would expect. So higher prices lead to lower probability of choosing. They're also responding negatively to higher fuel and higher smoke, but positively to more convenience. And this positive coefficient on the traditional stove indicates that there's a positive probability to choose the traditional opt-out choice, all other things being equal. Okay. But we didn't just stop here. We also used a statistical model that allows us to see if there's a lot of variation in responses to these attributes. And so these standard deviations, the fact that they're positive and large in many of these attributes indicates that there's a lot of variation across the sample, heterogeneity in how people respond to price, fuel requirements, and the traditional stove itself. So what we do is we then parse this data a little bit more, looking for patterns in the choices to see if there are different sets of households who respond to these attributes in similar kinds of ways. And we do that using a latent class analysis. And we find 3 classes, the first class being sort of a class that favors the traditional stove a bit and has fairly high price responsiveness, so they're fairly low demand households. The second class, which is a higher demand type household, that also responds negatively to these traditional stoves, so they seem to be more willing to try new technologies. And class 3, which really isn't responding to anything, and we kind of call them the uninterested class, that they're sort of making random choices. They weren't really engaged in the whole exercise in the first place. So now we're going to see if these classes adopt stoves in the experiment differentially. The other thing we can do is we can see if there are certain things that socioeconomic characteristics, demographic variables that are associated with being in a particular class to see if we can classify these households further. I'm going to spend a lot of time on these results, but we find things like wealth and age and gender being related to some of these classes. Okay, so what does the stove experiment look like? Well, first, before we wanted to set up this experiment, given the fact that the literature was highlighting low demand results, we wanted to design this carefully in ways that would address some of the barriers to adoption that have been identified both in the literature, but also that we could see in our baseline data. And so we did an extensive literature review, collected this baseline data, ran some pilots where we tested different features of an intervention, and then finally focused in on an intervention. And what did our intervention look like? It had 4 main components. One was an information component designed to address low knowledge of this problem, where we would show information about different stoves being promoted to households on a sheet with some pictorial diagrams to help with understanding. We did household demonstrations of 2 technologies in every household that was chosen to be in the promotion campaign. And this involved training sales teams and then doing these demos in communities. Then to address liquidity constraints, we allowed all households to pay over time in 3 equal installments. And we then we randomized some rebates or incentives to lower the price of the stove to households to see if offering a higher rebate and a higher incentive, higher price discount would lead to higher adoption. Control households didn't receive any visits, any of these features, and the treatment households got all of them, but the rebate level was different. So you can see our control sample is about 300 households. Intervention sample is the rest. It's a larger group. And within that group, these rebate levels were randomized. This low rebate is basically not a rebate. It's 2% of the stove. So it was really testing the effect of the information and the demonstrations. And then this high rebate is the 1/3 of the cost of the stove. All right, so do we see that these preference categories predict adoption? Well, we looked at the classes alone as predictors, and they don't have a lot of explanatory power, but we do see that this uninterested class, the people who were sort of not really engaged in the discrete choice experiment, they were about 10% less likely to adopt a stove. And without a rebate, that's about half of the percentage adoption rate. So we were getting about 25% adoption, and this group is 10% less likely, 10 percentage points less likely to adopt. Latent class 2, which was this sort of low demand, the high demand class compared to class 1, they don't seem to adopt at a higher rate. That's kind of interesting. When we add in the rebate as a control variable, these don't change a lot. We do lose some statistical significance here, but the results are essentially consistent. And then we add in a bunch of other controls, and including electricity supply, whether the sales NGO had a history in that community, and we see sort of the same result. Okay, so it seems like this, at least this uninterested class, there is some information in that we wouldn't have necessarily observed without doing that experiment. Some other notable results that I'll just highlight before we close and have some questions. One is that this NGO history variable does seem to have a small effect, although it's not statistically significant in those models I just showed you in terms of the adoption decision. But when we analyze use from the follow-up survey, it has a much larger impact. So sustained use of these technologies seems to be linked to whether that NGO is around and maybe promoting the technology on an ongoing basis. Also, we find that this class 1, this group that was low demand but somewhat more averse to smoke relative to the other attributes from the discrete choice experiment, they were particularly likely to adopt electrical stoves. And when we did the discrete choice experiment, we only framed it as biomass burning cook stoves. Our pilot experience showed that demand for biomass burning stoves was in fact somewhat low, and we think part of that is this class 1, these households, and they were quite likely to adopt the electrical stoves in particular that we promoted in these villages, which are a completely different technology, and maybe that experiment didn't provide as much information about. Class 2, which was the high demand group, they were more likely to adopt these biomass burning stoves, as we might have predicted based on the choice experiments. And then finally, this class 3 household, they seem to be also less responsive to the incentives. So that's consistent with this idea of not being interested in the product. Although, because of power, we don't see a statistical difference there on those coefficients. In conclusion, I think there is a great deal of information in these choice experiments in terms of who might adopt these stoves and who might not. And this is something that could be done relatively cheaply by people promoting these technologies or targeting these in a more appropriate way. Could lead to more cost-effective promotion of stoves, given that we have this problem of predicting where we could get high adoption rates. So if we knew ahead of time this community is likely to respond to this technology or not, then we could save money. And it's not easy to get to these rural communities in the Himalaya.
So I'm Rick Larrick. I'm a professor over at the business school. I'm a psychologist by training, and that is the theme of this session. We're going to have 4 papers on essentially the psychology of how people think about energy use and some environmental threats. So I'll kick us off. Adrian Camilleri will then follow and talk about the value of presenting energy use information to people on different scales to kind of get their attention with larger scales. Troy Campbell will talk about the fact that you can overwhelm people if you focus too much on climate change and it seems too threatening. So can we make solutions to climate change more palatable, especially to conservatives, with a different framing? And Kaitlin has been doing work on a kind of overconfidence effect in kind of political leanings and environmental issues, and she'll be building on that as she talks about her work. So I'll kick us off, and the paper I'm going to present is on political ideology and the adoption of energy efficiency. And the intuition here is that we may have to be careful at times about pitching products and savings in energy through a green lens. That if we focus on the green emphasis, could we potentially end up losing some of the consumer base as a result of their skepticism about climate change or their dislike of seeing themselves as green or having others see them as green? So this is essentially a test of that question. Can we find evidence that there is that kind of backlash effect? And it's with Dina Gromet and Howard Kunruther at Wharton. Where am I pointing this? Behind? Here, if you get it to work. Oh, maybe is there a little thingy up there? Yeah, there we go. Okay.
Okay, try now.
Okay, good. Okay, so this is a paper that was published in PNAS last year. There were 2 studies involved. One was just a 500-person online survey of what are the reasons why we should be adopting more energy-efficient appliances and products. And what was interesting about people's attitudes toward this is there are a couple of domains or reasons in which there's agreement between the more liberal part of the population and the more conservative, which is reducing energy costs is a good idea. There's a lot of agreement that that's a good reason to adopt energy-efficient products and a good reason for the government to even endorse energy-efficient products. Same thing with, and obviously this is only a subset of products, but to not be dependent on foreign oil is also attractive. The place where we get a big significant difference in terms of support is as a solution to climate change. The liberals believe this is also a good reason to focus on energy efficiency, but we lose some conservatives there. So this is just an expression of attitudes about why the country should emphasize energy efficiency, why individuals should adopt it. We wanted to see if that would translate into behavior as well. And so in a second study, we had people come into the lab, and unfortunately this paper is going to become outdated very quickly since it's going to pit the choice between an incandescent bulb and a CFL, which at least at the time, a couple of years ago, was still relevant to people. We're in that space now. We're going to have to move to CFLs versus LEDs. And unfortunately, the price difference right now is so big that it would mess up the ability to do these studies. But for now, we took advantage of a moment in time where there were these technology differences on energy efficiency, where people were given a real $2, and they were told, you must purchase one of these 2 light bulbs, either an incandescent one or the efficient CFL. And actually, before I jump to that, They were given information about the energy use and cost savings of a CFL relative to an incandescent bulb. So they were informed of essentially the 75% reduction in energy use and costs that come from using a CFL rather than an incandescent. And then in an experimental design, we manipulated whether there was a label on the CFL that was essentially blank, it said nothing, or that said protect the environment, a green label condition. So half the subjects see one kind of combination, the other half see a pair with where the CFL has no label, a blank one, or the CFL has the green label sticker. And then we simply varied the upfront cost of the bulbs relative to each other. We made them the same price for half the subjects, 50 cents each, or we captured what has been more historically true, which is a premium for the CFL, where they would have to pay 3 times as much, $1.50 versus 50 cents for the incandescent. And so we created a balanced design with a full factorial experiment. And I'll show you the results in a couple of different formats. So here's one way of looking at it. If we look at the percent choosing the CFL, if we look at the group that faced the same cost and there was no label on the CFL, and we break it down by liberal in gray and conservative in yellow, we get everybody buying the CFL. It's a no-brainer to them. They're the same price, and the one saves me a lot of money, everyone buys it. If it's the same cost and there's a green label on it, we still get everybody buying it. It's like the conservatives recognize a good deal. Everyone wants the CFL in this case. It gets more interesting in the next 2 cells. So we have the CFL costs more. You have to pay a premium. So of course, we're losing some people buying it at this point. But without that label about the environment in it, they're buying it at the same rate, liberals and conservatives. And so the punchline that you're probably anticipating now, if you put that green label on it and you make them pay a premium for it, we now lose the conservatives. The liberals are kind of buying it at roughly the same rate as they were before, but we're losing the conservative end of the dimension. They don't want to see themselves as green. They don't want others to see them as green in the process. And just one other way of graphing the same data, this kind of shows you across political ideology that if you have no label on it, you have a very flat function here of politics translated into choosing the CFL, but we have this kind of quadratic shape with the green label, where in fact, we're actually losing people who are relatively in the middle of the scale as well. And with that, I am done. Thank you.
So I'll be telling you today about some work that Rick and I have been doing for the last couple of years. And it's culminated in this paper looking at redesigning the fuel economy label and how that impacts on people's preferences for fuel-efficient vehicles. So I'll begin with this sticker that we're probably all familiar with. It's evolved in the last few decades. So it began with something quite simple, focused on MPG, and then it evolved into this label, which you'd be more familiar with. So MPG was still emphasized, but now there was also this annual fuel cost metric that was front and center. And the more recent label that's been redesigned and is now being rolled out is this one. And so you can see that it has added a number of different metrics. So let me sort of walk you through some of these. And I've highlighted them in different colors. So here in the top left, in yellow, we have consumption metrics. So we have this MPG here. We also have a gallons per 100 miles metric now. There are some cost metrics. So we've got an annual fuel cost, and we have a you save. You can also read you spend this many dollars in fuel over 5 years. So it's a relative cost metric here. And we also have 2 environmental metrics in the bottom right hand. So we've got a greenhouse gas rating and a smog rating. So lots of metrics. All of these are very highly correlated because they're all talking about the same thing, which is the fuel economy of the vehicle. So we are interested in a number of different questions. The one that I'm going to focus on today is if you were just going to choose one of these metrics to present to people, which would that be in terms of increasing people's tendency to prefer an efficient vehicle? And we'll be focusing in particular on the consumption metric and the cost metric. So what we did was we ran several online experiments. So this is all stated preferences. There are no actual vehicles being purchased in these experiments. And we've presented people with a choice between 2 vehicles. And we have given people one efficient vehicle that costs more and one inefficient vehicle that costs less, basically. So there's a trade-off there. And we're asking people whether they prefer the fuel-efficient or the fuel-inefficient vehicle. And so along the y-axis here, we'll be looking at the proportion of efficient vehicles chosen. So a higher bar means that more people prefer the fuel-efficient vehicle. And there are 6 cells in this design. So we are comparing 2 metrics expressed along 3 scales. So we've got a consumption metric, or we have a cost metric, and these are going to be expressed along 100 miles, 15,000 miles, or 100,000 miles. So the 100 miles, you'll remember, is the current one that's being used here, gallons per 100 miles. And we'll be comparing that with 15,000 miles, roughly annual driving behavior, and 100,000 miles, which is roughly lifetime behavior. So the figure here shows you 2 things should jump out immediately. We've got a U-shaped function, and we have the black bars are taller than the gray bars. So let me quickly walk through these results with you. So in terms of the black bars being taller than the gray bars, this means that people were more likely to choose an efficient or prefer an efficient vehicle when the efficiency was expressed in terms of cost than consumption. And in the paper, we expand upon some of the underlying psychology behind why we think this is the case. We've called the metric fluency and metric compatibility. Basically, cost information is more easily processed by people, and it better integrates with the problem that people are trying to solve, which is cost minimized, presumably anyway. And as for the U-shaped function, I think the explanation comes from 2 forces that are basically additive here. So one is this idea of scale expansion. As you increase the scale, the numbers increase, and in previous papers that Rick has been involved with, it's shown that people pay more attention to larger numbers, and so that characteristic or feature accrues more weight in the decision. And so we expect this linear function. What we also found here was that there's a scale fluency effect. So people are much more familiar and comfortable with this 100 miles metric as opposed to scale, as opposed to 15,000 and 100,000. And so people were sort of had 2 forces here that basically caused the 15,000 miles scale to be least likely to cause people to prefer the efficient vehicle. So to give you the results very quickly, people prefer more fuel-efficient vehicles when fuel economy information is expressed as the cost of fuel over a very expanded scale. And more generally, this doesn't just apply to the psychology of labels. In vehicles, it can be applied to many different vehicle labels. So we would like to present people with problem-compatible familiar metrics on larger familiar scales, I think is the take-home message. And so you can read more about this in a paper that's coming out this week, I think, in Journal of Public Policy and Marketing. And there's also lots of stuff there on my website. So thank you very much.
Hi guys, I'm Troy. I'm from Fuqua, and I'm going to talk to you about solution aversion. So there's a lot of problems in the world, and we know that people often deny those problems. And the main theoretical model of why people deny it is because we think they're scary, because they make us feel bad, and because they're so aversive, so apocalyptic that we just don't want to consider them. So we deny the problem. And there's an idea if we bring in solutions to these problems, not only will we actually solve the problem, but we'll reduce the amount people will deny it because the solution will make the problem less scary because now it can be solved. However, if you think about a lot of the solutions that we present for these problems, they themselves are scary, especially to certain people. They can include taxes, war, and in the case of climate change, some pretty stringent government regulations. At least that's the dominant social narrative right now. And so what we argue is often when people are denying the problem, it's not because of the problem qualities itself, or at least it's not entirely because of those problems, but it's really about the solution that is motivating this denial. And we think this can explain a lot of what's going on in climate change. Because we know in the United States and across the world, people deny climate change, but we know that this is really part of a certain type of group more than other groups. So that group is people who tend to have more conservative values. So that's the Tea Party. That's people who are, pro-free government, anti-any government regulation. And though it's not perfect, a catch-all category that works very well in our studies is affiliation with the Republican Party, especially those people who are more Tea Party free market Republicans. And it makes sense because the climate change solutions are let's use government regulation to regulate the thing that conservatives love, the free market. And ideology is really, really important to people. There's a lot of research showing how focused and how important ideology is to people. They want to protect it. They want to see it as right. If you're like me and you're in a business school, you have tons of friends on Facebook who are really, really pro-free market, and they post about it all the time. It's really, really important to their soul, to who they are as a human being. And climate change narrative is more or less saying, hey, this thing that is really, really important to you sucks at solving the fundamental, most important problem of our generation. And not only is it so bad, we need to bring in a solution that is completely antithetical to everything you believe in to solve it. Right? So that's not something you want to believe in. And so that's our solution aversion argument. And so what we did is we brought people into our studies, and we bring in Democrats and Republicans, and we have a bunch of different measures, so I'm just going to be showing you representative graphs. But we show them climate change science, and we see this effect, is the idea that Democrats are much more likely than Republicans to agree with the climate change science. When we bring them in and we show them the climate change science, and we show them, we say, hey, there's this really popular solution, big government, the graphs look exactly the same, because it makes sense, because the dominant social narrative is big government. However, this is what we've seen in every single polling data for the last 15 years, this graph. When we bring in Republicans and Democrats and we give them a pro-economy solution, and the idea is we can solve climate change by green energy, making lots of money, and exporting our technology to the world, the graph that we have seen for 15 years attenuates and starts to go away. And in some follow-up studies, what we do is we really show that this is really about the free market ideology that people have, is that it's the Republicans who have the strongest free market ideology who are the most likely to deny, who are the ones that are moving around the most when we change the solution, and their specific opinions about the economic impact of the solutions, it is what's statistically driving or statistically associated with their beliefs on climate change. And so I didn't come here to pick on conservatives or anything. We have lots of other studies on solution aversion. I'm not an environmental scientist. I'm a psychologist, and solution aversion is a more general theoretical model we're proposing. And we see that liberals engage in solution aversion in other issues we look at. If I came here to pick on anybody, I came here to pick on marketing people, the people who've been communicating climate change for the last 15 years, because pretty much this is what's been going down. Hey, everybody, there's this huge, massive, apocalyptic problem called climate change. But do not worry, because we have something you all love, a big government solution. And it's just no wonder that this hasn't worked or hasn't resonated with conservatives and hasn't resonated with a pool of people that continues to deny it and leads to less individual and societal level action to solve the problem. And so I think really what we need to do is we need to take the people who understand the psychological drivers behind it, who know how to properly market this stuff, and then find the people who actually know what real policies we need, what the real science is. And I don't know those things, but I know these things, and I know some of you people know these things. And if we can actually come together, then we can communicate climate change in a way that is honest and targeting the actual policies we need, but framing it as best we can, but still in an honest way that can be convincing to other people. And that's, I think, how we get some movement, both on an individual and societal level, to stop some of these issues. Thank you very much.
So I am Kaitlin Toner. I'm actually now at Vanderbilt. So I want to thank you all for letting me talk at a Duke event. I did get my Ph.D. here at Duke in the psych department, and this is an ongoing collaboration with some Duke colleagues. So as Troy mentioned, there's a lot of ideology about people's attitudes, and I'm going to explore one kind of driver of these kind of motivated reasonings, the ways that people avoid new information and stick with whatever they believe in the first place. So I'm going to be talking about belief superiority, and this is the view that the belief that one's own beliefs or opinions are more correct than alternative views. So when we study belief superiority, we always ask two questions. The first is always an attitude question. So what do you believe? What's your opinion on this issue or this topic? And then we ask a second question, which is, how much more correct is your view on this topic than alternative viewpoints? So people can say anywhere from, my view is no more correct than other viewpoints, all the way up to, my view is totally correct, it's the only correct viewpoint. And people differ on this. And my colleagues and I have looked at this in a number of domains, and we always find the same pattern, which is that the more extreme someone's attitudes are on a given topic, the more superior they tend to feel about those attitudes. So this is from a study on politics, and these were 10 different political issues, and you can see that the more extreme people's attitudes were in either a liberal or conservative direction, the more superior they tended to feel about their attitudes. the people who endorsed the more moderate positions in this study showed a little bit more humility about their beliefs. So the first thing we wanted to do in the current study is just to see, does this pattern hold true for energy and environment topics as well? And we also wanted to see what are the consequences. So I can feel as superior as I want, and that may not matter unless that's somehow affecting my interpersonal relationships, my ability to take in new information, or my willingness to compromise on these tough topics. So to do this, we ran a study here in North Carolina, actually at the Raleigh Flea Market, and we asked people about different energy and environment topics. So we asked them about what are your beliefs and your feelings of superiority about 10 controversial energy and environment topics. So this is just really briefly. You can see that the same general pattern emerged as in the previous research. So the more extreme people's attitudes were on, say, climate change, for example, the more superior they feel about their position. And that's true for people who are at the extreme end of, yes, climate change is happening, I'm very alarmed about it, all the way over to, I dismiss it, it's a total hoax. People who were in the middle show a little bit more humility. Now, for two of these topics, when you ask people about how much focus there should be on the price of electricity or whether offshore drilling should be allowed in North Carolina, here we didn't get significant quadratic effects. But for the others, we did. So then we wanted to take this one step further and say, what are the outcomes of this feeling of superiority? So for this, we focused on hydraulic fracturing in North Carolina. As I'm sure you all are aware, this is a controversial topic in the state and was certainly being hotly debated last spring, which is when we ran this study. So we had people, after they reported about what they believed, we gave them an op-ed article, so a fake op-ed article, and they either got one that argued for allowing fracking in North Carolina or one that argued against it. And these articles were exactly the same, we just changed a couple key phrases to make them either pro or anti-fracking. And then we gave people a chance to rate the author of the article, on how warm they thought he was and how competent they thought he was. And warmth and competence are these primary traits on which we judge other people. So by asking about these particular traits, it gives us a sense of how they generally view the author. So I'm about to show you data for people who read the pro-fracking article or the anti-fracking one, and we'll look at the results for people who were high in belief superiority first. So the red line is people who opposed fracking, the blue is people who support it, and what you can see is that when the author agreed with their position, people rate him as being warm and competent. When he disagrees with their position, whatever that position is, they're rating him as worse on both traits. So they're not liking the author as much when he disagrees with them. When you look at the same results for people who are low in belief superiority, we find that it doesn't matter whether the author agrees with them or not. So they're just rating him in the middle. It doesn't matter whether he agrees. We also asked people about their feelings of certainty about their beliefs. So certainty is related to superiority, but it doesn't have that same element of not only am I right, but my views are better than yours. So we asked them about how certain they were about their fracking beliefs before reading the article, and then we asked again later to see if that certainty changed over time. And what we found is that the higher people were in belief superiority, the more they tended to increase their certainty after reading the article. And this was true even if the article had disagreed with their beliefs. So no matter what, they're feeling even better about what they believed in the first place, even if they shouldn't necessarily. So just really quickly, we found that as in other domains, extreme environmental views seem to be associated with more feelings of belief superiority. And this superiority seems to have important outcomes. So it's leading people to derogate their opponents, and it may be leading to greater polarization. If you're only getting more and more certain about your own views when faced with new information, it doesn't bode well for your ability to consider alternatives or compromise. Thanks.